Hello everyone, welcome back to the Trick Spot. So in today's video we are going to learn about an oxidation reaction which is known as Dakin reaction. It is also known as the oxidation of phenolic aldehydes and ketones. So first let us know what is Dakin reaction and later we'll solve the mechanism of this reaction. So let me write the statement of this reaction first. So it says the replacement of aldehydes and acetyl groups in phenolic aldehydes and ketones by a hydroxyl group using alkaline hydrogen peroxide is known as Dakin reaction. Okay, so let us read it once. So it is the replacement of aldehydes and acetyl groups in phenolic aldehydes and ketones by a hydroxyl group using alkaline hydrogen peroxide is known as Dakin reaction. So whenever we have an aldehyde group, like we have CHO in its phenolic form, then that CHO will get converted into OH. And whenever we have an acetyl group, that is a phenolic ketone, so that is represented by OAC or OCOCH3, that is known as acetyl group, methoxy group. So these groups will be known as phenolic ketones. This was phenolic aldehydes, that is CHO with a benzene ring and an OH is my phenolic aldehyde. And if I have an acetyl group with my benzene ring and the OH, this will be my phenolic ketone. So this again will give me an OH. Okay, so now let us see a reaction, or you can say an example of this type of reaction. So the example which I am taking right now will be a benzene ring with an OH and a CHO. Now this reaction uses H2O2, that is hydrogen peroxide, and NaOH, that is sodium hydroxide. And in the later half we do hydrolysis. So what we get as the product will be catechol. So in place of CHO, I get a OH group attached. Okay. Now let us come to see the mechanism of this reaction. Okay. So the reaction mechanism involves two steps. In the first step, we have our H2O2 and the NaOH reacting together. So I take my H2O2 plus my NaOH. So this will give me OOH plus H2O. Okay. So from hydrogen peroxide I get my H2O and one O remains, and that O reacts with the OH to give me OOH. So this OOH will be of great use in the next step. Okay. So in this case I am taking a phenolic aldehyde. That means here will be my OH phenolic and here I have a CHO group. Okay, so to this I'll be adding this part which will come from the reagent. So that is my OOH. Now what happens in the first step is that this O double bond between the carbon and the oxygen will break, and this will form a single bond with oxygen, and hence it creates a valency. So the valency of carbon will not be satisfied when this becomes a single bond. So at that point of time, this OH or this OOH will attach itself to the carbon to give something like this. So my OH will be as it is. The double bond carbon with the oxygen will become single bonded. This H will be as it is, and this OOH will attach itself over here. Okay. Now let us see the next step. Now, in the next step, what happens is this oxygen has a lone pair of electron, right? So that lone pair will be given out to this. So there will be another bond formation taking place between carbon and oxygen. This OH will go out. So first this OH will go out. This negative charge will give its lone pair to the carbon. So that will form a bond with carbon and oxygen, a double bond. And what happens then when this OH goes out, this oxygen will have a negative charge. So this negative charge, in order to become stabilized, this has a greater electronegativity than carbon, right? So there will be a bond formation taking place between this oxygen and the ring. So you get something like this. We have a benzene ring as it is. The downward OH will be as it is. So what happened in the previous step was this OH was going. So we'll not write this OH in this place. And this oxygen will form a double bond with the carbon. And this oxygen has a lone pair and a negative charge. So this oxygen has more electronegativity than this carbon. So this obviously will not be bonded to the benzene ring. This will bond to the benzene ring. So we have this O. This CH will be as it is. Okay. Now this benzene, as we said that this oxygen will form a double bond. So I'll write a double bond. So we will have something like this. Now in this part, we carry out hydrolysis. Okay. So when we carry out hydrolysis, we have H and OH. So what happens is, my H and OH will attach itself in such a way that the H will attach to this part of the molecule and the OH will come over here. Okay. So what I get will be two molecules or two products. One will be with the H and one will be like that. So I'm making. So as I said, one will be this one. So that will be OH and another OH. And the other will be CHO and another OH. So that will be HC double bond O OH, which is nothing but my formic acid. Okay. So this was the mechanism for aldehydes. And this is what all we have done today. So that's it for today. I'll be making a video on ketones soon. So please till then like, subscribe and share, and give me ideas if you want to give any, and please mention in the comment section if you have any queries. Thank you so much for watching.